Right, good morning. In this video, we are going to look at the trigonometry questions of November 2015 question paper for grade 12s. Right, so let's just jump right in. This is question 5. It starts by saying, given that sine 23 is square root of k, determine in its simplest form the value of each of the following in terms of k without using a calculator. Right, so if sine 23 is k, I'm going to have a triangle there in quadrant 1, where quadrant 1 normally is, for 23 degrees. And if sine theta is root k over 1, that means that my opposite, sine is opposite over hypotenuse, so my opposite is root k and my hypotenuse is 1. And then you can calculate that missing side there using Pythagoras. So I have x squared is hypotenuse squared minus the other one squared, and this is then 1 minus, and root k squared is going to be just k. So x is then the square root of 1 minus k, positive because it's going on the course diagram on the positive x-axis direction. Okay, so I have square root 1 minus k for that adjacent side of the 23. Okay, and then I can continue answering my questions. I have 5.1.1 sine 203. 5.1.1 is sine 203, which if I use my reduction formula, I can write 203 as 180 plus 23. Thinking of reductions, placing it in quadrant 3, where sine is going to be negative, so this is negative sine 23. And since my question is sine 23 is root k, negative sine 23 is going to be negative root k. 5.1.2 is now cos 23. For this one, I'm going to need my diagram. So I'm just going to read off the diagram. Cos 23 is root 1 minus k over 1, which is then root 1 minus k. And then 5.1.3 is tan of negative 23. Boys and girls, you can think of negative 23 as lying in quadrant 4. Because on the course diagram you have 0, 91, 82, 73, 60. And if I go negative, I go around that side. So same as 360 minus theta lies in quadrant 4. 0 minus theta also lies in quadrant 4. So this is now 0 minus 23, which is in quadrant 4 where tan is negative. So I have negative tan 23, and then tan 23 is going to be opposite over hypotenuse, which is then a root k. I just wanted that negative root k over 1 minus k. And then you should always, in grade 11 and 12, when you have a square root in the denominator, just rationalize the denominator by multiplying with that square root over itself, so that this becomes negative root. I can somehow put that in 1k times 1 minus k, put that in one root, and then root 1 minus k times root 1 minus k is going to be 1 minus k. This last step, just rationalize the denominator. Alright, so that's negative tan 23. Question 5.2. Simplify the following expression to a single trigonometric function. Single trigonometric function, that means I just want sine something or cos something. I don't want sine times cos or tan over cos or something like that in my answer. So I have 4 cos negative x plus 90 cos negative x cos 90 plus x over sine 30 minus x cos x plus cos 30 minus x sine x. right. Okay, so this, yet again, I just said that a negative angle lies in quadrant 4 where cos is going to be positive. So I have positive cos x there, 4 cos x, and cos of 90 plus x. 90 plus x is going to place it in quadrant 2 where cos is negative, so this is going to become negative sine x. You must always remember at 90 and 270 plus and minus to change between sine and cos. And then this one, I'm tempted to expand this using sine 30 sine x, sine 30 cos x minus cos 30 sine x to use the expansion. But quickly just look at the entire, before you do that, because that's going to make this incredibly long, just quickly look at the entire thing here at the bottom. The entire denominator, it's sine cos plus cos sine. You see this is already the expansion, so I can actually make this shorter using my compound angle formula. And sine cos plus cos sine is the formula for sine of A, which is now 30 minus x, plus B, which is x. Okay, so this is sine A cos B plus cos A sine B is the formula for sine A plus B. And then the sine 30 minus x plus x is just going to become sine 30. So here I have minus 4 sine x cos x. I just multiply the sine and the cos with one another, and I swapped them like I write x, y, z. If I have y times x or x times y, try to write it in alphabetical order. When I multiply sines and cos and tan, I try to write it in the order sine, cos, tan as they appear on the calculator. Alright, so I just multiplied the sine and the cos with one another, and then this is just sine 30, which if I use my special angles, whatever method you use, sine 30 is going to be 1 over 2. So this is negative 4 sine x cos x divided by 1 over 2, and then that becomes negative 4 sine x cos x times 2 over 1, so times 2. And I'm not going to multiply the 4 and the 2 with one another now. I'm just going to keep them negative 4 times 2 sine x cos x. The reason for that is because I also noticed that the sine x cos x makes me think of the double angle formula for sine. 2 sine x cos x is now sine 2x. And the question said I want this in a single, this is sine 2x, a single trigonometric function. So I don't want a sine and a cos, I just want a sine. Like that, I'm done. Okay, then question 5.3, general solution type question. I'm just going to turn this page over. Right, question 5.3 says determine the general solution of cos 2x minus 7 cos x minus 3 is equal to 0. Right, when I do trigonometric general solution, I always want to aim to work with only one ratio in my equation, so only sine or only cos or only tan. Sometimes it's possible that you have a sine and a cos, but when you factorize, they factorize into separate brackets that one only has sine in and one only has cos in. That's fine. But as far as I can, I try to get one trigonometric ratio. Now, since I have cos here, I'm going to replace this cos 2x with the formula. Cos 2x has 3 formulas. I just want to quickly double check. Here's my formula sheet. I quickly just want to double check the formulas. Let me quickly show you as well. Okay, so I have cos 2x that can be cos squared minus sine squared 1 minus 2 sine squared, or 2 cos squared minus 1. Now, since this equation has a cos in it already, I'm going to work with a formula that has cos in it only, not sine. So 2 cos squared minus 1. Right, so I'm going to replace this question here with 2 cos squared x minus 1 minus 7 cos x minus 3, and then I can add the like terms there, so I will have 2 cos squared x minus 7 cos x minus 4, and this looks like a quadratic equation, 2x squared minus 7x minus 4, the quadratic trinomials. And you can either factorize or use the quadratic formula here. I think it's not going to be that difficult to factorize, so I'm going to factorize it quickly. If you use the quadratic formula, that's perfectly fine as well. So I'm going to have minus 8 cos x plus 1 cos x is going to give me the minus 7. There we go. Right, so I have the two formulas here, making 2 cos x plus 1 equal to 0, or cos x minus 4 equal to 0. And this produces cos x is minus 1 over 2. I'm sure most of you know, or all of you know how to get there. And cos x is equal to 4, jump the 4 over. Now, since if you think of the cos graph, lies between minus 1 and 1, it's not going to go through for a normal cos graph. So this answer here is not applicable. But from this one, I can get my general solution. Just note that it is possible to have general solutions, to have valid answers at both sides, and then you will have to do this that I'm doing here for both. It's possible to have actually answers in 4 quadrants if you have this scenario where both answers are valid. In this case, this one not valid, so I'm just going to work with this. Right, now to do general solution, two things that's important. Your reference angle, even if that's negative, always take a positive value to get your reference angle x, is then going to be shift cos of half, which is one of the special angles, and it's 60. Shift cos of a half, but you see I don't use negative, I use the positive, and that is then special angle 60. So I have cos x, cos of 60 is a half, but now I was working with a negative where cos is negative in, if I think of this, cos is negative in quadrant 2 and 3. So I'm going to place this angle then not in quadrant 1, but in quadrant 2 and quadrant 3. So even if that's negative, you keep it positive so that your reference angle that you work out lies in quadrant 1. Then you can place the quadrant 1 angle in the correct quadrants where the ratio is positive or negative depending on the question. But if you use shift cos negative a half, let me just show you. Shift cos negative a half. For cos, it's going to place it in quadrant 2. So then you have an angle here in quadrant 2, which is a bit uncomfortable to place in different quadrants. Or if you were working with, say, for instance, sine or tan, it's not necessarily going to place it in the same quadrant all the time. So the safe thing to do is just have your reference angle in quadrant 1 so that you can place it where you need the ratio positive or negative depending on the question. That's the first thing. The second thing is not applicable in this question. I just want to mention it. If this is not only x, say it was a 2x or a 3x, keep it 2x or 3x and first place it like that in the quadrants, is equal to plus k 360, and then you're going to divide the 2 out. Do not, if there was now 2x, don't write here x is 30 and then place the 30 in the quadrants. Keep it 2x is 60, and then you're going to place the 2x in the quadrants, and then from there, after you did your general solution, you can divide with the 2, because it's also going to affect the plus k 360 is going to then become plus k 180 or whatever the case may be. Right, so to place an angle in quadrant 2, I'm going to typically take 180 minus theta, so 180 minus 60, which is 120, plus k 360. K is an element of Z. And to place an angle in quadrant 3, I'm going to take 180 plus theta, so 180 plus 60 is 240, plus k 360. K is an element of Z. And this is general solution. Right, just to mention as well, extending this to other questions, this plus k 360k is an element of Z literally means you can take multiples of 360 and add or subtract it to 120 to produce more answers than only 120. It's a formula that basically creates a number pattern starting at 120, and that arithmetic number pattern that adds 360, 360, 360, but this number pattern goes both ways. So you start at 120, you add 360, add 360, add 360 to create more answers that will also be valid for this, and you can also subtract 360, subtract 360, you can also go back. That's what this means. So here as well, 240, if I use that as a starting point, I can create a number pattern plus 360 that will create more values. That's also valid for this. There's an infinite number of answers, and this is the formula to write down the infinite numbers of answers. Okay, if they ask a specific solution, just so you know what that means. Question 5.4. Right, question 5.4 says, given that sine theta is a third, calculate the numerical value of sine 3 theta without using a calculator. Right, so sine theta is a third. I want the numerical value, meaning a number, not something with an x or a theta in it, a number, 20 or a half or a quarter, a number, value of sine 3 theta. Okay, so I'm going to write sine 3 theta using my grade 12 formulas. I'm going to start by breaking it up into 2 theta plus theta, which is then almost now 3 theta. And then this I can use my compound angle formula for. So this is going to be sine 2 theta cos theta plus cos 2 theta sine theta, and I'm trying to get to angles with only theta in it because I have something workable numerical for that. 2 theta I also want to replace with something. Using my formulas, sine 2 theta is 2 sine theta cos theta. Cos theta times another cos theta is going to make that 2 sine theta cos squared theta, plus, and then cos 2 theta. You can replace with anyone. I'm just going to replace with the 1 minus 2 sine squared theta version of it because I have something for sine, which is great. If I can just keep it sine, it just makes my life easier. But you can replace anyone. There wouldn't matter because you anyways need to make a plan with cos as well. So 1 minus 2 sine squared theta times sine theta. Okay. I think there's quite a few things you can do from here. You can take out the sine theta as a common factor, leaving you 2 cos squared plus 1 minus 2 sine squared, and then the cos squared and sine squared you can maybe group to get rid of the cos squared. So you can rework this with mathematics to simplify into only sine theta values, or what you can do, clever trick that you work with quite often, is if sine theta is 1 over 3, then this is going to be 3 squared 9 minus 1 squared is 8, so this is going to be root 8. by Pythagoras, and then you can just read the cos theta from there. So that's something you can do as well. Okay, so you can work with that. I'm going to try and do the mathematical challenge here just for those that are interested. Okay, so I'm going to take out the sine theta as a common factor, leaving me 2 cos squared theta plus 1 minus 2 sine squared theta. Okay, and then, but you see this is cos squared minus sine squared. It's not cos squared plus sine squared, which is the formula for cos double angle. Yeah, this is not going to work at all. Okay, no, so mathematically, you're just making your life more difficult to work with a triangle. Okay, so I have 2 sine theta, which is a third, cos squared, which is then, if I square this, it's going to be 8 over 9. Root 8 squared is 8. 3 squared is 9. Root 8 over 9 plus 1 minus 2 sine is a third squared times sine theta, which is a third. And I'm supposed to work this without a calculator, so I'm going to try and do that. This is becoming 2 over 3 times 8 over 9 plus a third squared. A third squared is a ninth, so times 2 is going to be 2 over 9 times a third, and then I have 2 times 8, 16, 3 times 9 over 27, plus 9 over 9 minus 2 over 9 is going to be 7 over 9 times a third, and this is then 16 over 27 plus 7 over 27. So 16 plus 7 is 23 over 27. 23 over 27. Oh, I went off the screen. Okay. Alright, so there is question 5.4. Let's look at question 6. Question 5, 6, and 7 are the trigonometry questions. So we're going to look at those 3 questions. Sorry. Okay, there's question 6. In the diagram below, the graphs of cos x plus q and sine x plus p are drawn on the same system of axes for minus 240 to 240 from negative 240 to 240. The graphs intersect at 0, a half there, at half 0 it cuts, minus 120, negative 1, and also at 240, negative 1. 240, negative 1. There are points of intersection that they give me the coordinates of, determine the values of P and Q. Right, so fx is this graph, which I can see it's a cos graph. Looks like a cos graph as it is normally, but my cos graph normally from 1 to negative 1, and this one starts at a half, which means it's been moved down a half unit. And also normally it goes to negative 1, but now it actually goes to negative 1.5. So I can see this cos graph has been moved down 1 unit, meaning that Q, a half unit, so that Q is going to be 6.1. That Q is going to be negative a half, moved down 1 unit. And then sine x plus P. Okay. The gx is a sine graph. Now, sine graph normally starts, if you think of your sine graph, that looks like that. It normally starts there at the 0 point, so I'm looking for that. It's this point here where my sine normally starts, which I can see has been moved back. If this is 60, that should be 30. So this is marked every 60 degrees, so half of it should be 30 degrees. The sine graph has been moved back 30 degrees. And if it's moved back, that should be plus. The P works the wrong way around. So that should be x plus 30. Since there is a plus already, the P is then just 30. If that was a minus, just be careful of that. If they gave it to you as sine x minus b, you want there to be x plus 30, then you must make your p negative to effect that sign there. All right, okay, so there's my P and Q. 6.2, determine the values of x in the interval given here for which fx is bigger than gx. So this is the graph of f. You see that? I want to look where f is above g. So here f is below, below, below. There it goes above. From where x is negative 120. X from negative 120. Oh, I actually want to, sorry, not to include it. From where x is negative 120, it's above, 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 up until where x is 0. Then it goes below again. So up until where x is 0, and then I just want to check it stays below, below, below. So that's my answer. The reason why I don't include these values is just because they asked in the question if x is strictly bigger than gx. If they said bigger equal, then I want to include the cutting points as well, the intersection points, and then I would include it here. Okay, or this, you can write it in interval notation, or you can also write it like this: x lies between negative 120 and 0. Set builder notation, both are fine and accepted. Right, 6.3. Describe a transformation that the graph of G has to undergo to form the graph of H, where H is negative cos x. Okay, so if I look at G, it's this graph. I want to think, where can I take this graph so that this graph becomes a graph of negative cos x. Now, negative cos x, let me just quickly think here for a second, brainstorm. Cos x looks like that, so if I make it negative cos x, I'm going to flip it to look like that. All right, so negative cos x graph would look like this. Okay, so I want to move this graph around so that it looks like that one. Now, you can do one of two things. You can just take this point here, search for it on the graph. There it is. This graph does move between -1 and 1, and just move this there to the 0 point. So move it forward 120 degrees. Right, so that's something you can do. You can take the graph of gx, which is currently sine of x plus 30 degrees, and then just move it forward 120 degrees. To move it forward 120 degrees, I'm going to subtract 120 from this. So make it sine x plus 30, subtract 120 degrees. So describe the transformation. I can move it 120 degrees to the right. Or something else you can do is you can work with this point, flip the graph, or reflect the graph in the x-axis, and then just move it back. That's 60 degrees. So that's something else you can do. You can take G, reflect it in the x-axis, and I'm going to move it back 60 degrees to the left. Right, since I just want the transformation, you can just in words write move it 120 degrees forward or to the right. Alternatively, for the other one, reflect it in the x-axis and move it 60 degrees to the left. I just want to show you the impact it has on an equation. To move it forward, it would look like this. If I worked with the reflection, gx is sine x plus 30, the reflection is going to be placed in the equation by a negative. They didn't ask that here, but I just want to make sure you also know the effect it has on the equation, because they do ask that sometimes. So the reflection in the x-axis, and then to move this graph that's currently there 60 degrees back, I'm going to add another 60. So this will then be minus sine x plus 90. That will be sine x minus 90. And you'll see if you use your reductions that it is the same equation. All right, which is negative cos x. Okay. That's question 6. Let's look at question 7. This is 3D problem with your sine, cos, and area rules. It says a corner of a rectangular block of wood is cut off and shown in the diagram below. The inclined plane, that is ACD, is an isosceles triangle. So those two sides are the same length. Having angle ADC equal to angle ACD, ADC, that angle, equal to ACD, that angle, which is theta shown. Also, angle ACB, ACB is a half theta, AC is x plus 3, AC is x plus 3, and CD is 2x. Determine an expression for CAD in terms of theta. CAD, that angle, since that is theta, and theta is going to be 180 minus 2 theta, which is not difficult. CID is equal to 180 minus 2 theta. They're just trying to guide you, give you some assistance for the next question, I suppose. Question 7.2, prove that cos theta is x over x plus 3. Okay, so I'm thinking cos rule because there's cos, and cos rule I typically use in triangles that does not have 90 degrees in, and since in this question I have that x plus 3, 2x, I have all of the side lengths, and I have the angles. I can use the cos rule, and since they made me work out that angle now, I think that's probably going to be my angle that I work with. So this is the side in the cos rule, which is a squared is b squared plus c squared minus 2bc cos a. This is on your formula sheet, by the way. The angle that I work with, the side across from it must be alone on this side. So I'm thinking I'm going to work with this angle, and that's then going to be the side that comes alone. 2x is going to be my small a, so 2x squared, and b and c is then both x plus 3. So I have x plus 3 squared plus x plus 3 squared, since those two are the same length, minus 2b is x plus 3, c is also x plus 3, so I'm still going to make that x plus 3 squared times cos a, and cos a is then going to be 180 minus 2x. I'm not working with this as my a, since that is an angle a, just to mention. You can use any angle of the triangle, but since they asked me this size, I'm thinking they're trying to guide me and help me to specifically use that angle as my a. 180 minus is quadrant 2, where cos is negative, so this I can reduce to negative cos 2x. So I have here 4x squared is x plus 3 squared plus x plus 3 is going to be 2x plus 3 squared. I just add like terms, minus 2x plus 3 squared, and this becomes then plus, so this is negative cos 2x, which if I multiply this negative somewhere there in front makes that a plus. Okay, cos 2x, I'm trying to get, oh, theta, whoops, that should be theta, sorry, because I already have x's there. Okay, I'm trying to get the cos alone. That looks like that. So, I think Let's just quickly take out 2x plus 3 as a common factor there. So I have 4x squared, 2x plus 3 squared, 1 plus cos 2 theta. And since I'm trying to get cos alone, cos theta, I'm going to replace the cos 2 theta with the plus 2 cos squared theta minus 1 format, and then the 1 minus 1 will cancel out. So now I have 4x squared is 2x plus 3 squared. 1 minus 1 is 0, so times 2 cos squared theta. And I want the cos alone, so I'm going to take all of this to the other side. The 2 times 2 is 4. And x plus 3 squared is cos squared theta. The 4's cancel, and since I want cos theta, I can take the square root to have cos theta is square root, and square root is going to get rid of all of those squares. And I want to show that cos is x over x plus 3 is what I wanted to do here in this question, so I'm done. Okay, and then question 7.3, last question quickly. If it is given that x is 2, calculate AB, the height of the piece of wood. Right, so I want to calculate this. I have there a half theta, and I have here theta. Okay, so if x is 2, let's just work with this quickly. If x is 2, I can see that cos theta is 2 over 2 plus 3, which is 5, right? Cos theta is 2 over 5. And I can use this actually to calculate the value of theta. So I have shift cos of 2 over 5, and that gives me 66.42. Theta is 66.42. Right, I'm just going to round that off. And now they want me to calculate the length of this AB, which in this triangle I have a 90 degree, meaning I can just use my normal sine, cos, tan ratios. So sine is opposite over hypotenuse. I want the length of AB. The hypotenuse, if x is 2, is going to be 5. And I have an angle half theta there. So if theta is 66.42, then half theta is going to be 33.21, right? Okay, so I have that sine of half theta is equal to AB over, I'm going to show you sine of half theta is AB over x plus 3, which if x is 2, then that is 5. So AB over 5. That means that AB is 5 sine half theta, and 5 sine half theta worked out is 33.21, and you can literally just type that into your calculator. AB is 5 sine 33.21, which is 2.74 units, centimeters. They don't give me centimeters, so I'm just going to make that units. All right, and that is the trigonometry questions of November 2015.